Got your notes, please. First and foremost, notice the replacement. Set 55 in the book is a Maclaurin series, and while Maclaurin series are awesome and super useful, they're also not top one material. They're top two material, and they're a little out of place, so although I would love to teach them, if I can get to them later, I will. We have bigger fish to fry, so the problem is this. This is the most common AP free response question there is in calculus. And it's not in the book, so I got to put it in somewhere. And so let's do the Calc 1 material instead. So here it goes. Today, hopefully, I will communicate or introduce you to what's called an integral defined function or an area accumulation function. Now, think of it this way. Let's start here. You know lots of functions. You know linear, and quadratic, and cubic, and trig, and exponential, and log. So many functions. Absolute value. There is also a function for integrals. All those are things you do. You know, the square root function. Besides just square rooting a number, we could say there is a function that square roots anything that comes along. Well, integrals are a thing that you do, and so we could identify a function that is defined as an integral. In this case, for example, I'm saying g of x is an integral defined function. And as far as the variables go, let's start there. Let's understand the variables. You can see that it says g is a function of x, yeah?
Yep.
And yet in this here, it seems like you've got u's going on. What the heck is going on? Well, think about that in terms of fundamental theorem. When I do the fundamental theorem, what do? I find the antiderivative and substitute in the upper limit, which would be x, and the lower limit, which is -3. So g of x is true because after I do the antiderivative with u's in it, what goes in for u is x. And so it eventually ends up as an x function. U is called a dummy variable. It is a placeholder, if you will. It is just meant to hold a place for x until x goes in after the antiderivative is performed. You with me?
Yep.
All right, cool. Now, as far as g, besides an integral defined function, you'd also call g an area accumulation function. Here's why. If I said, what is g of -3, then if I put -3 in for the x in the function, then doesn't that mean I write a -3 up there? Do you follow? That means g of 3 is the area accumulated. This is the curve, by the way. This is F's graph. I don't think I ever labeled that in my work, which is atrocious, but that's the F graph. The g of -3 is how much area you get from going from -3 to, well, to -3. So how much area do you accumulate? Zero, because that's an area with no region, so that's 0. That's kind of boring, but g of -2. G of -2 would be the area accumulated from -3 up to -2 going in for x under the F curve. I wish I would have made a lot of little graphs, but if you were to show this, the area accumulated from -3 to -2 would be that part of the graph. G of -2 then represents that shaded area. How much area is accumulated? G of -1 is the integral from -3 to -1 under F. And so we accumulate a little more area. Would G of -1 be more or less than G of -2?
More.
More, because we're getting more area now. All right. So you're probably starting to get the gist. G of 0 is from -3 to 0 under the F curve. Shading-wise, that would be the full semicircle. All right. G of, what is, just for fun, funsies. What is g of 0 equal to? Now, if you're thinking, oh, do I have to write the equation of that and integrate? That is the most definite. You are to use geometry. So, by geometry, it is pi r squared over 4. So 9 pi over 4. Yeah. Good job, Tom. 9 pi over 4. You follow? Do not try and write the equation and integrate that. That'll make a mess of this problem. So just use geometry. All right. G of 1.5. G of 1.5 is the area accumulated from -3 up to 1.5 under the F curve. Now we're starting to get a little triangle action. What is that equal to? 9 pi over 4, we still have that area, plus we're picking up some triangle area. Plus 3 times 1.5 over 2, and we'll just leave it at that. Again, geometry. And then G at 3 is the area accumulated from -3 to 3. And I'm going to start to say this a little different. It's the signed area accumulated. -3 to 3. Now, I constantly say the wrong thing. I say area under the curve, but I should say, and most people say the same thing, but it should be area between the curve and the axis. So when I go over here, please don't draw over here, which is infinite area. That's not right. Okay, it's the area here between the curve and the x-axis. Now that I added that signed area in, what happens with the areas of the triangles? These cancel, and so we're right back to 9 pi over 4. All right, cool. Now, let's go on then to a little bit of calculus. There are 3 relationships between G and F. The first is the one that's given. I'm going to strip off the variables, the independent variables, U and X, and boil it down to just G is the area accumulated under F. That's given. Now let's go to some layers of calculus. What if I took the derivative of both sides? What's the derivative on the left?
G prime.
And the derivative of the right?
F.
Is just F, because on the right, the derivative of the antiderivative is just the thing, right?
Mm-hmm.
What about G double?
G double equals F prime.
F prime. All right, so they're separated by a layer of calculus. They're one layer of calculus off from each other. And that makes sense. Now, we're going to combine those ideas with some of the big ideas of calculus, which we've done a ton, but just some of them are G, actually, I'm going to not say G. A function is increasing if its derivative is positive. A function has a relative max if its derivative goes positive to negative. We could also do a min. A function has an inflection point if its second derivative changes sign. Yeah? A function is concave up if
the second derivative is positive.
if its second derivative is positive, and so on and so on. You get the idea. Okay? Now then, we'll do some sample problems, and I gave you a little hodgepodge of these. Usually, this would have just about every type of question except for absolute extreme, which we haven't done. But it'll be a good starting. All right, so here's typical questions and what the work should look like. So, say I gave you this function f. G is still the integral defined function that we talked about earlier. Oops. Let's talk about some questions. They might say, find where G is increasing. So you would first get in the big ideas of calculus and start going there. G is increasing where G prime is positive. We just said a function is increasing where its derivative is positive, right? So G is increasing where G prime is positive. What is G prime's connection to F?
Oh, I know.
G prime is equal to
F.
F, okay, and it's in there somewhere, all right? So G prime is equal to F, so where is G prime or F positive? -3 to 1.5, all right? So we're gonna say G is increasing on -3 to 1.5 because, first the big idea of calculus, because G prime is, and then we're gonna connect it to what we're given. They didn't give us G prime, we're connecting it to F is positive. Okay, now you could also give the justification first, or hey, this is where I'm looking. You could say the function G is increasing where G prime is positive, G prime is equal to F, and F is positive on, then answer. I like this better, I think it reads clear. All right, find where G is concave up, justify. All right, so big idea of calculus, G is concave up where? G double is positive. What does G double have to do with F? F prime. What is F prime? Slope of the F graph. So we need to find where the slope of the F graph is positive. Okay, so there's 3 steps of the deduction there. Where's the graph positive? -3 to 0. So we're going to say G. Be careful with your articles. Obviously, you don't want to say GF when you mean G, or G prime when you mean so on. So G is concave up on -3 to 0 because G double, which equals F prime, which equals F slope is positive. It would not be enough to just say because G double is positive. They didn't give you G double. You made an inference. You have to communicate that inference. All right? Find where G has relative extrema. Justify. So, calculus-wise, relative extrema happen where G prime changes sign in some fashion, right? And then we'll figure out what kind of extrema. So, and G prime equals what in F? Just F. So we need to figure out where G prime or F changes sign, which is at 1.5. All right. And what kind of extrema? Min or max? Max because F changes. All right. So here we go. G has a relative max at because G prime, which equals F, goes positive to negative. Okay? Cool. All right, more basic calculus that we're applying in a different way. Find the equation of a tangent line to G at x equals 0. What do you need to do a tangent line?
Point and a slope.
A point and a slope, then you write point slope. Okay, so we need a point. Can you give me anything about the point?
0.
Yeah, good deal. X equals 0. What about the y?
3.
Okay. Do I want F at 0 or G at 0?
I want
G at 0. So maybe you should actually say, well, what does G of 0 mean? G of 0 is defined as the integral from -3 to 0. I think we actually already found this above, didn't we?
Yes.
The area accumulated. G of 0 is the area accumulated from 0 to -3 to 0, which is 9 pi over 4. So the point is 0, 9 pi over 4. All right, cool. We've got a point. Now how do we find our slope?
G prime.
M is G prime, which equals F at 0, which is 3. Okay, so our slope is 3. Now what do we do?
Point slope.
Point slope. Hit me. Y?
Minus 9 pi over 4.
Y minus 9 pi over 4 equals
3x.
3x minus 0, which is 3. Cool? Okay. Find G at 1.5. We already found G at 1.5 above, didn't we? G at 1.5 is the area accumulated from -3 up to 1.5, and we said that was 9 pi over 4 plus the triangle. Is that correct? 1.5 times 3 over 2, and we'll just call it that good. All right. What about G prime at 1.5? That's F at 1.5. And F at 1.5 is, obviously you need to communicate that. You don't just state that in your head but not write it. You have to get that on the paper. It's equal to F at 1.5, which is 0. Okay? And G double, first connected to F. F prime at 1.5. How do you find F prime on a graph? Slope of F, which is, how'd you get -2? Oh, you went from here to here. Yeah. Down 3 over 1.5, or if you like, it's all one big line, down 6 over 2, but it is negative, or down 6 over 3, right? -2, yeah? Okay. All right. Find the x where G has a point of inflection. Big idea of calculus. Inflection is where? Derivative changes sign. So G double changes sign. What does G double have to do with F? F prime, which is what for F?
The slope.
All right. And where does the slope of F change sign?
1.5. 0. Oh, yeah.
0. Do you agree?
Yeah.
This is the point where slope goes from positive to negative, and that's the only place. So G has an inflection point where G double, which equals F prime, which equals F, slope of F, changes sign, and that is at x equals 0. It should be nowhere. All right, this is a hard one, and I'm going to let you think about this for a minute. Those of you guys that are killing the class, maybe this will challenge you a little bit. I had about 3 people get it in BC, and so we'll see how you can do it, okay? Suppose the graph of F is periodic. So in other words, it repeats this pattern. Semicircle line, semicircle line, semicircle line. Over and over again. It repeats this graph over and over. Find G at 21.
Oh, let's do that.
G at 21. Figure it out.
Is this a trick question? It is. But I think it's roll F.
Pretty clean, it's fine.
Okay, so it equals -3. That's is mentally please. Oh my gosh. Wait. Wait, 6?
Ready? All right, Henry.
9 pi.
9 pi.
It's a
9
9
pi.
pi. It's actually 9 pi.
63 pi.
Undecided.
It is 9 pi.
Let's go.
Okay, so what is 9 over 4? How much area is accumulated in one period?
9 pi over 4.
9 pi over 4. One period is 9 pi over 4. All right. Now, wouldn't you agree G of 21 is the area accumulated from -3 to 21? I don't know if this is necessary, but think about this. How long is one period?
6.
6. So one period would go from -3 to 3. One would go from 3 to
9.
9. One would go from 9 to
8. 15.
15. One would go from 15 to
21.
21. So altogether, I did give you full periods, which their problem was a little harder. They didn't have full periods. But altogether, 4 full periods. Each one is 9 pi over 4. And so it is 9 pi. Nicely done. Well done. Okay. It would not be continuous. It would just be, like, yeah. And it doesn't have to be. All right, good deal. Would you flip this over and just do one quick one to see if you understand this individually, not anybody else, just you. So I give you this function f that looks like that. It's quasi-linear, or two lines, 2 triangles, if you like, or 3 triangles, depending on how you look at it. My question A is, where does G have a relative extrema? And question B, with justification. Question B is, where is G concave up? I'll give you a second to think about that. This isn't drawn very well.
Does it go through?
It's supposed to. I'm going to draw this a little better. Let's go with just the open interval, by the way. Don't worry about the endpoints. Just interior relative extrema. Okay, ready? All right. Who wants to give A go? Huh? Henry. Oh, Brian, wait a second. Brian, go ahead. I haven't heard from Brian.
So it has to be where that
I agree.
so set x equals 2, g doesn't match because g goes.
Beautiful. All right. So at x equals 2, G prime, or sorry, G has a max. Love it. You did have to say what kind of max, not just a max or an extrema, but a max. At x equal 2, because G prime equals F, he tied it to F. Wonderful. Switches or changes or goes, whatever you want to say. It's positive to negative. Well done. All right. What about B? Matt, give B a go.
G is concave up on 0 to 1 because G prime equals F prime, or G double equals F prime equals slope F is 1.
Wonderful. All right. G is concave up on, they would not grade for the endpoints, so if you had parentheses or brackets, it would be okay, but I would prefer parentheses. Because G double, which equals F prime, which equals, he tied it all the way back to what was given, F slope is positive. Okay, cool. Wonderful. It sounds like we're doing well. We'll do a free response tunnel practice on Friday, and we'll probably do about 12 of these this year. It's got to be killer. All right. So we have two things. I'd like to get you, at least let you see your test, and then I'd also like to get questions on 55. So if you get 55 out, actually I have a little bit of bad news for those of you who had the blue version. In switching around the questions, I actually covered up a question. So there's a question you haven't done yet. And so if you had the blue version, I need you to do that question. So this is a test. Do not receive nor give out in any fashion.
I'll figure out a blue version. I want to do a question hard.
I should just assume these are alternating, but I just want to make sure. This question, please. Really, test me this question, please. Yeah, if you have white, you don't have to do this. You did the question already on your test, but it's the blue version that didn't have this question. Do not help each other. It is a test. The white version I will get you out in just a minute. This question, please. It's a medium difficulty level question. Hopefully it will pull up. All right. That's all the blues I have. What did you have? Did you have blue? Oh, okay. Oh, that's right. Okay, because you guys were right. Yes, K is a constant. Just don't know. All right. I have not decided on any kind of scale yet, so don't get too high or too low. I did not do any partial credit on the multiple choice, so obviously in a case like that, we have to scale a little bit. So scale will be decided later. At the very least, you'll see how you did. Oh, when you're done with that little slip, I'll take it. Everybody have their test? Oh, I didn't see yours. I think yours is in a totally different folder. Oh, that's in the wrong. I'm sorry. Thank you. This is not something. So the people with the white version, the first number is how many multiple choice you had correct. The second number is your free response points. So I'm still working out a rubric or scale. I need to look at the blue version before I make a decision. Shared. without saying, people that have your score already, if you're already at 90% without even scale or even close to it, then you're really killing it because of their. Thank you. All right. Thank you. What questions do we have on 55? We'll go over this test tomorrow, so we're just going to do questions on 55 now. 12, 21, 35. Okay. Thank you. Any other? Last one, does it have a number? Okay. All right. Please, oh, sorry, I should have told you, put your phones away, please. Feel the hand your phones out while that test is out. And I will give the people that just finished that little question a chance to look at their test as well. They just finished. And I'll come back. The multiple choice is out of, eventually it's right for you guys to take, but with this, it'd be great. And so that's the, we don't have this for. So your multiple choice, there are 19. In the free response, there are 13 points there, 9 for the AP, and 4 for the point of inflection question. And I'll figure out a scale and vote. Okay, is anybody still working on that little sheet? Okay, cool. Can I, sorry, before I forget, I'm going to just take the tests back. And I will give them out tomorrow to, not to keep, but to look at in greater detail. And overall, I'm pretty darn happy. Our free response average on that phone question is 6+. That's pretty good. To be on track for a 5, you need a average 6s on the free responses. That's pretty good. All right, sir. Thank you. Thank you. I'll come back to that one. All right. Here we go. Is 12 still a question on the old
Yeah,
homework? All right. This will be a rough one.
it is. I'm getting a new number.
All right. So, let's, I'm just going to ask questions. So what did you do to start with? You're trying to...
I drew a picture.
You drew a picture. Excellent. Did you put it on the coordinate plane?
Yes.
You should. Remember in your notes, we said when you do a geometry problem, if you can help it, you want to put it on the coordinate plane so you can use your equations, all that, instead of just some floating rectangle. All right, so the rectangle could be short and wide, or tall and thin, or just more squarish, whatever. There are lots of different rectangles, and they have different areas. We're trying to find the best one, all right? So now, what did you do? Okay, before that, let's get clear in our head what we want. What do we want? We'll maximize the area of the rectangle. Then an equation. All right, so base height, I like it. Let's go xy. Is it xy or 2xy?
2xy.
It's 2xy. And so, okay, so do I want to
Not doing negatives.
start a prime positive to negative and start taking derivatives with 3 variables?
No,
Not if I can help it. What can I find another relationship? Okay, so you should always ask yourself, well, did they give me the circle as some kind of distractor, or am I supposed to use it? Well, Look at any of these x's and y's. Aren't these x's and y's related by being points on the circle? No matter what the configuration, x and y are related by being on the circle. So the other is the equation of the circle. X squared plus y squared is 9, or y is the square root of 9 minus x squared, because it's the semicircle. Really, we're dealing with the half of the circle, the upper half. You could do that actually, because that's where the equation of a circle comes from. That's wonderful. If you think of this in a Pythagorean theorem way, that is where our circle equation comes from, is the distance formula. The Pythagorean theorem in a circle is all. Good job. I like it. So you should get the same thing.
Good morning, Dublin Jaguars. Please rise for the Pledge of Allegiance. Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now check your derivatives. Product rule and change.
Welcome Red Rock Community College today in the counseling office for 7th hour. Sign up in counseling to attend their meeting. If you are interested in learning more about overcoming test anxiety, sign up today in counseling and go to E100. Friday during 7th hour, there will be a pep rally.
Check your derivative.
To follow. Because
So
of
like
the
a
pep
half
rally
a
on
period,
Friday,
I think
Mr.
it's
Griffin has given
two
permission
channel.
for boys mentoring to have their egg drop tomorrow instead of Friday. You'll need to sign up in counseling and report to your mentoring group. Get your capital materials together and bring them tomorrow. Attention boys!
Okay,
If you are interested in boys volleyball for the spring, we are
so
having
let's
a
get a common denominator.
November 7th hour in the library. Please come if you think you might want to play volleyball during the spring. Summer high school baseball meeting is today at 7 p.m. in the cafeteria. This also includes 8th graders that will be staying at Devlin for 9th grade.
Cleaned up.
Boys that have big lockers for the fall sports, please return your locks to Mr. Perico ASAP. We need to get ready for winter sport athletes. Thank you. Please come by Mr. Perico's office before school or right after.
So A prime is 0 at.
The GHS cheer team has 2 competitions this week. Come out and support them this Thursday at Greenwich High School at 7 p.m. and Saturday at 6 p.m. at the National Western Stock Show Complex, where they will compete to win a bid to national. They need your support winning in 5A teams such as Valor and Columbine. So come show your support to the team that always supports you.
Whoa.
Come out and support Emily Devontae, Jerry Hickok, and the Greek Mountain team. Compete to the national title as a 4A state meet
18 over 4.
Friday, November 8th at Thornton High School. The
I
individual
reduced it.
on Saturday, and the girls will find out on Friday if they qualify for any individual event.
Right?
Yeah.
Okay.
Senior high students, all students
Okay.
in grade 10 will
So,
participate in the
dimensions.
during 7th hour. Today, if your last name begins with H through K, you will meet in the counseling office, and Summer through Z will be in the
Base is 6
100.
over root 2.
A reminder that
The height is just straight up y.
the musical are today after school at 2:40
It's
in
3
the
over root
auditorium.
2 if you.
Ladies, don't forget that there will be a girls soccer interest meeting today in
This
the cafeteria after
and
school.
2y equal 9 minus x squared.
Attention Jack, would you like to have you and your friend's hilarious childhood photos in
Find the
yearbook?
area
Visit
to
your
be.
Finder childhood pics, more recent or a major throwback, for the opportunity to recreate them and relive your happier days. Send them to yearbook.jags@gmail.com or DM them to the yearbook at Dazzling Jags. A special congratulations to the Devlin Marching
Hey.
Band on their 8th state championship
21?
this weekend, scoring their highest score in Devlin history.
Or
They did
25,
an
what should I
awesome
go?
job this weekend in Grand Junction. Make sure to show them some support.
Okay, let's do 25, then I'll do 21 if I
Hey
can.
Jack, your daily day of the day. In honor of the band state championship, it's National Saxophone Day. That's all your announcements, Jack. Have a
The
wonderful one.
sum of the squares is 200. That's the minimum product. Okay, so let's write an equation for product. What are you going to call the variables? X and Y, or A and B. Fine. Okay, that's 3 variables. So can we get it down to 2? How do you take this? Sum of squares is 200. Okay, so Y is the square root of 200 minus x squared. Yeah. So this actually looks a lot like the previous one. X times 200 minus x squared. B prime then would be first stays the same. Derivative of the second. Right, chain rule, product rule, plus second stays the same, derivative of the first. Are you down? Regular common denominator, I get negative x squared plus 200 minus x squared over 200 minus x squared rooted. And it seems like I'm going to get an x of 10 up there.
Yeah, but then the other y was also 10, and that's not what this was.
Y is not 10?
No, y is.
Oh. And they didn't say x and y
Yeah,
are 10?
the answer to Q is
Really?
I got 10 for both.
Oh, then I don't know what's going on because I'm getting 10 or 10.
Yeah,
It's not a these.
So the answer is none of these.
Yeah.
Oh, cool.
no, it said the product, yeah, the product. And that was in the, that was the,
Is that a math? Oh, that's a math.
Dude, whoever wins this Alabama is gonna be number one.
Oh, I just found a math. I didn't check.
yeah, I was getting it.
That's a math, and not a min. That's why.
Independent
Okay. Have a good day.
game, I think they would be.
That's why we check for min or max. I guess I went too fast. Yes.
Really?
Yes. Oh, there was a bingo. Three. It was three. Oh, it was three.
I did. That's fine. What was the test out of? Did I?
32.
Out of 32 so far. So you should. Oh, this is. Oh, you took the derivative, not an antiderivative.
Oh,
Yeah, I think it should have been k x squared minus x cubed over 3.
Oh, okay. I was like going that way up here, and I was like,
Oh,
wait
you
a
were right.
second.
That was the right thing.
I'm gonna put my name on it though.
Oh, yeah, okay. Alright, we're cool.
Thank you.
Thank you, sir. Have a great day. Okay. Alright, so. Alright, read those. Have a good day.